All right, we're gonna get started here. Sorry for the delay and everything. I had to wrap a couple things up. It kind of snuck up on me a little bit. So we will get started now. All right, so welcome to Study Hall, everybody. If you're new here, this is a place for you to come bring your questions regarding beginner and intermediate Python. My streams are oriented around getting people ready, getting your Python skills ready, basically to pass the TI. And if you're in premium prep, we're going through the material. And in study halls, things are a little more free form. Mostly it's a venue for you all to ask any questions that you might have. If there's any sort of side topics, things that maybe we don't discuss in Learn, either maybe at all, or in maybe we don't discuss it in very much depth, or maybe we're not covering it in premium prep. This is a place to have those interesting side discussions. I think it's really important to have those kind of fun rabbit holes to be able to dive down. But it's also important to know, like, okay, here's a side topic, and here's like what we what we at Galvanize are emphasizing as like sort of basic readiness skills. I definitely want to give people an opportunity to like have fun with Python and with programming and data science and explore, and also keep focus on the material that is important for readiness and passing the technical interview as well. Hey everybody, looks like we got some people saying hi in the chat, which is great. Gonna lurk for a bit and then share a question or two. Yeah, you're welcome. Yeah, feel free to pop in your questions as soon as you've got them ready. Also, feel free to lurk for a bit too if you want to do that. That's totally fine. So yeah, this is like I said, mostly this is a venue for you all to bring in your questions, and sometimes I'll prepare a special topic. And maybe do kind of a special lecture that maybe we don't have time for in premium prep, or maybe if I've gotten a lot of questions on something, I'll prepare something. A lot of times I'll just solve Code Wars problems and just talk about writing tests. That's a big thing. If you've seen me do many streams or lectures at all, you know how big I am on tests. And talk about light TDD techniques, test-driven development techniques. Talk about how to deal with errors, and focusing on sort of practical skills and problem-solving skills with Python. So today I was a little delayed. Obviously, I just had to. I remembered I had to respond to a Slack message, and I was like, okay, if I have to do this now before I forget. And so I don't have anything particularly prepared for today. I was thinking we could just go through either the material or Code Wars or something. Just kind of have a regular day, and if anybody's got any questions, just feel free to throw them in whenever you're ready. Cool. We got a couple people saying hi in there. All right, cool. So it looks like we haven't progressed that far through the material. I recently kind of started over. Let's just see if there's anything interesting in here. Yeah, because I know a few of the people here are recognized from being in premium prep, and we've moved a bit beyond this material, but let's see. This is just going to talk about assignment and incrementation, comments, printing, indentation. You know what? These are still important topics. They're foundational, and they're kind of taken as a given, I think, at this point in premium prep, but there can be some subtle complexities to these. So I think it's worth going through these, even though we're kind of a little further on. Okay, so this lesson on incrementation, the goals for this lesson are to appropriately define variables in Python, use variables in basic mathematical computations. So let's see here. Let's see what we can do. So there's a little bit going on. If we do, let's just make a simple variable. Let's just have a equals 10, something like this. Variables really aren't terribly complicated. And the odds are pretty good, even if you're very new, even if you're not in premium prep, even if this is your first stream, that if I write some code like this, that this probably does something that you could probably pretty easily anticipate the behavior of this correctly. But there might still be some questions around the edges. So let's kind of dive into this a little bit. So I have this variable a equals 10, and we call it a variable because if I want to assign it to something else, if I want to reassign it, its value can vary. I can reassign it to 20, or I could reassign it to negative 3.5. Whoops. Always put your negative numbers in parentheses. It's a good rule of thumb. Side note, but always put your negative numbers in parentheses no matter what. If you don't know why, just do it anyways. Or don't do it and discover why the hard way if you want. That's always a good classic way of learning, is learning the hard way. It's done me a lot of good. So cool. I could also reassign it to a different data type, like a string or something. So I can assign this, and this first assignment of this value 10, of the integer 10, to the identifier, which is the name portion of a variable, is called an identifier. So this first assignment brings the variable a into existence, right? So after this, which is on line 3, in my editor right here, you see line 3, the lines are numbered on the left there. So after line 3, a exists in my code. There's an identifier that exists called a, and I can, anytime I type the name of that identifier, it's going to access the value that I assigned to it, right? So let's just kind of play around with this. So first of all, let's just say I access it before I make the assignment. So one thing that's important to know about the way that Python executes code, we have the Python interpreter, which is a program, and it starts like you and I do at the top of a document, and it reads it. Well, I say you and I, but I should say like the English language is written. Not, of course, not every language is written top to bottom, left to right, but of course English is. So Python, being an English-based language, right, is starts at the top of the document at line 1 and goes through each line from left to right, and each line from top to bottom. So top to bottom, left to right, just like reading English. So at this point, line 3, and I moved everything down, obviously. On line 3, if I try to access A, I'm actually going to get an error. And let me actually run my code here. Let me invoke my interpreter. Invoke. Somebody was saying that using the word invoke made them feel like a wizard, which it should, and very much is part of the reason why I talk about invoking things, because it also makes me feel like a wizard, and that's a cool feeling. So I'm invoking my interpreter down here. You can see I'm printing a here. I'm trying to access this variable a, and it hasn't been defined yet, right? And if we look, we're the Python interpreter, we're going to come up here, we're going to look at this comment, not do anything with that. We've got an empty line, we're not going to do anything with that. And it says print a. okay, well, it knows what the print function is, and it's going to try to access this value a, but there's no value that's been declared to that point, right? So on line 3, as of line 3, a does not exist yet. Even though it exists in this document, it doesn't exist at this point. So it's always good when you're learning something, it's always good to keep track of your errors, the errors that are possible to get. One thing that I like to do is if I write a line of code that gets an error, which, if I'm learning a new feature, a lot of times I'll try to be more or less exhaustive and kind of explore around in the different errors. And I'll try to write a line of code that gets that error, and then I'll save the error in a comment, either on the same line if it's short enough to fit on the same line, or maybe I'll put it on the line above or below. And then I'll comment out that line, obviously, so it doesn't give my code an error, right? So if I'm learning a new feature, a new library, something that I'm not familiar with, which is something that, in technology, you're always learning something that you're not familiar with, which is cool. It's always there's always something new, and it always kind of keeps you like pushing your own understanding, and it's a lot of fun. To me, one of the important things is learning about the errors, like what errors are available for this, what are the limitations, what may I not do in using this, and understanding why, when and where those things occur and why those things occur, sort of secondarily why those things occur, helps you understand how to utilize those tools, right? So it's always good to note a few errors when you're learning something. So we can note that error there. So if I run this code, it's going to run again. It'll be okay. Okay, so let's do something like this. Let's just print a at every stage here. So let's say, boom, boom. Right there. Good. Okay. So a equals 10. If I try to access the value of a, think about what it's going to be. If I try to print a, it's going to be 10. Right? You can see I assign a to 10. We print a, we get 10. Assign a to 20. We print a, we get 20. Negative 3.5, we get negative 3.5. I assign a to hello, we get hello. Pretty straightforward. So more than just being able to capture this value in some identifier and have the value change for this while the identifier stays the same, which is useful unto itself, we can treat the identifier a as the value, right? So look at this integer 10. Well, I know that I can perform mathematical operations on numbers, right? So I could, for example, I could add, let's add 7 to 10. And just big surprise there, I'm going to get 17. So if I wanted to add 7 to a, it's going to add 7 to whatever the value of a is, which happens to be 10 in this case. I could add 7 to 20 here. Now here's an area where, if you're new, there could be a potential point, right? You could see potentially maybe different valid behaviors, right? Because you might look at this and say there are maybe several behaviors that you could expect, right? Does this change the value of a, or does this just tell me what a plus 7 is? And both of those are reasonable assumptions, or reasonable things to postulate about what might happen. In this case, all it does not change the value of a. It just tells us what this expression expresses the value of a, whatever a is, plus 7, and a is 10 at this stage, so plus 7. So that doesn't change this to like 17, and then reassigning a, doesn't mean that it's like we're adding 20 to 17 or something. So just to prove that, let's just isolate that down, right? So if I say a equals 10 and then print a plus 7 and then print a again, we're going to get 17 where I'm adding it to 7, and then we're going to get 10 again. We'll do that. And just to prove this, it's going to be, or just to note this, I like to keep little notes like this when I'm learning something. So that's going to be 17 there, and it's going to be 10 there. Boop. Cool. And let's see. Let's do this one as well. I'll just run these. So whatever the value of the variable is, we can just perform whatever operations we could perform on the type that it points at, right? So in this case, it's pointing at an integer, so we can do whatever we want. Anything we can do to an integer, we can do to a, because a, we would say, the way we would think about it and the way we would say it is a is an integer, because it is, right? A is pointing it to an integer. And same thing, floats and integers are pretty similar. We can do the same mathematical operations using floats and integers together, and a lot of compatibility there. It'll change a little bit when I change it to a string. I can no longer do the integer operations because it's a string, and strings don't necessarily support all of the math operators, obviously, because they're a different data type. So we deal with the information in under the terms of a string rather than under the terms of a number. So, but we could do any string method or other string operation on A there. Cool. All right. I do see somebody posted a question regarding Boolean flags. I'm thinking let's just try to fly through this really quick. I think this will be really quick, and then I'll get to that question. Okay. So what is the value of x after the following code executes? Oh, and I totally didn't. I was like, I know I'm forgetting something. So one thing that's really common to want to be able to do, let's do this. A equals 0. One thing that is very common is to want to change the value of a variable relative to its current value, right? So let's say I want to increment whatever the value of a is. Let's say I don't know what the value of a is, but whatever it is, I want the next value of a to be its current value plus 1. So we'll start it at 0. So I can say a equals its current value, which I can access by saying a. So what I'm doing here is adding 1 to its current value, right? This is a valid expression. 0 plus 1 is 1. So the right-hand side of this assignment operation, we call this single equals sign, we call it the assignment operator. The correct way to say this is a gets 0 and a gets a plus 1. I have kind of a bad habit of saying a equals. That's technically incorrect. A lot of people just do that and understand what you mean, although that is technically incorrect. I know it's technically incorrect, and I still just kind of do it anyways. But I'm trying to kind of curb it a little bit, or at least make it clear, this is an assignment, not a check for equality, which is a different and distinct operation that is possible. Maybe we'll get to that when I get to the Boolean flag question. Cool. So yeah, so the way this is going to work is that this expression on the right-hand side of the assignment operator, the single equal operator, that will evaluate first, a plus 1, and then once this expression is finished evaluating, once it's been reduced to its simplest form, which is, a plus 1 is not a complete or a fully reduced form, right? So we have to complete the operation until we get a value back. So 0 plus 1 is not a terribly difficult operation. The result of that is 1, the integer 1, and then that's going to be reassigned to a variable that happens to have the same name. So we're reassigning a according to its current value. So a equals a plus 1. This is such a common thing to want to do, especially with incrementation like this. And like we could do this any number of ways. We could say a equals 37, and then a equals a over b. This could be much more complicated, 3 or something like that, right? So this could be anything. But this kind of operation is so common that we actually have a shorthand way of doing it. So it's called incrementation or operator. It's called incrementation, the incrementation operator with plus, and yeah. So what this will do, let's put it like this. So line 28 is what we call syntactic sugar for line 29. And syntactic sugar means, in this case, you could say that like the Python interpreter sees line 28 literally as line 29. It rearranges the code to be line 29. So behind the scenes, it literally rearranges the code to look like from line 28 to line 29. So it just means, syntactic sugar just means that it makes something a little sweeter. It makes something a little nicer. And it doesn't, in this case, in this particular example, it doesn't save you a whole lot of space, but it makes your code clearer and just a little more concise. So you'll see this plus equals operation quite often. You might think, well, that's great, but what if you wanted to do like minus? Let's do this. Plus, minus, time. Something, I don't know. There's a bunch of them. Okay, so let's say minus, and we'll say times, and then we'll do divide. Oops. Yeah, divide. Floor divide. Can't say it comes up that often, but modulo equals or mod gets. These are all possible. So any of the mathematical operators, it's possible to use this way. Now this applies to any data type that uses some operator like this. So you might think of strings and lists, and tuples, for example, can use the plus operator to concatenate other data types to them. And you can do a plus equals or a plus gets with a string, and that'll concatenate. You can do a plus gets with a list or a tuple as well, and those will concatenate. But obviously these other operators don't apply to those collection types, so something worth mentioning. But yeah, all of these are gonna work. And let's do something like a equals, let's just do a equals 2. Oops. Yeah, so you might ask yourself, like, how do you do this with something like, what if you wanted to do like, instead of doing minus equals 1, for example, since subtraction, the order of the operands matters, it'll change the outcome, right? What if I wanted to do like 3 minus a or something? We can't use this shortcut for that, right? So the reassignment operation like this will only only work if A, if the variable name is the first operand in the expression and the operand on the other side of the equals is the second operand. So yeah, just something to know that it does have that limitation. So there's no analogy for this being able to do it in the opposite direction for operations that where the order of the operands is important. Okay, cool. So let's come to this. We've got x equals 10, x plus gets 2. So plus gets is a reassignment of x according to its current value. This is going to turn into x equals x plus 2, which is like saying x equals 10 plus 2. 10 plus 2 is 12, so x equals 12. Okay. Oh boy. What is the value of y after the following code executes? We've got a mod gets in here. I forgot we can also use exponent gets like this. This is fun, but just to be clear about this, there is a situation that I know of that uses this operation. I don't know that I've ever actually, maybe I'm wrong about this. I might have used one of these operations before, but I kind of think I've never used this sort of like divide gets or mod gets. I'm sure there's an application for it somewhere. It's not common though. These ones are common, plus or minus, some increment value, times equals, and like I said, I do know of a situation, a pretty useful situation where I use this one. But anyways, yeah, so let's look at this. So we got y equals 8, and then y mod gets 3, which is like saying y gets y mod 3. So that's like saying how many times does 3 go into 8, and what's the remainder? So 3 goes into 8 twice. 3 times 2 is 6. 8 minus 6 is 2. So 3 goes into 8 twice with a remainder of 2. So this is like saying mod gets is like saying y mod 3 or 8 mod 3 is 2, y equals 2. So this is like saying y equals 2. And then y times gets 2, which is like saying y equals y squared. So 2 is the value of y. This is like saying y equals 2 squared. 2 squared is 4. So it's like saying y equals 4. So the value of this should be 4. Is that what it's asking for? What is, yeah, okay, that's what we're looking for. Sometimes they'll put up the code and you'll make an assumption, but they'll throw you a curveball. We'll throw you a curveball with the thing there. So sometimes I got to read them. Okay, true or false does, oh, that false should be capitalized. True or false does the ID of X change after the following code executes? Yes. Anytime we reassign a value of an immutable type, integers are immutable types, what that means is that we don't have the capacity to change the value on the level of the value. We can change the identifier. We can reassign the identifier to a different integer, to a different immutable type. We can reassign the integer to a different integer, but that's changing the identifier from pointing at one integer to a different integer. It's not changing the integer to a different integer. And it's kind of a weird thing to describe with an integer because it's like I feel like I'm saying something that's so obvious that it's hard to express, right? Like we're not saying, well, we're not changing 5 into 2. I know that's not what the code says, but we're not changing 5 into 2. Let me give an example. I keep doing this thing where I try to like talk out a bunch of code and I'm like, I just need to write it. So if I say x gets 5, x gets 2, we're not changing the 5 to a 2. We're not going into the, the number 5 and displacing the value 5 in, with the value 2. We're not changing the number from one number to another. We have the number 5 that exists and the number 2 that also exists. And what we're doing is saying, hey, x, instead of pointing at 5, point at 2 instead. So since these, and the behavior there is that these are two distinct objects in memory. 5 is an object in memory, 2 is an object in memory. That's how I should have explained it. So instead, it's not saying we have one object in memory that is 5, and then we change that same object to 2. That we have two objects, 5 and 2. And then we're saying x points at 5, and then we're saying x points at 2. So each object in memory has its own ID, its own identification number, and that's different than an identifier. The identifier is the name. The ID, or the identity, is a number that is assigned to every object in your program's memory by the Python interpreter. So when we reassign a variable from one immutable type to another, then we change its ID because necessarily we change the object. Cool. All right. I always think these basic concepts, I'm like, oh, we'll just fly through this. And then I'm like, wow, there really is, it always surprises me. And it's funny because I do this. It's what I do all the time. I'm like, oh, variables. And then I'm like, wow, there really is a lot, kind of subtly a lot going on in the variables. They are, I don't want it to sound like, oh, you got to understand all this stuff that you missed or anything, but and probably everything we went over is, stuff that y'all understand at this point. But yeah, it's kind of cool to dive into simple topics with more precision and detail. I think it's all about getting good at the basics, right? Cool. So let's jump into this person's question. They're asking, would I be able to go over accumulators, Boolean Flags, challenge 3 at some point? Yes. It seems like an easy one, so not sure why I can't seem to get it right. Can I? Oh, yes. Please do share your code. I was just going to ask for that as well. So looks like we're in Boolean Flags, challenge 3s, and basic prep. Okay. Feel free to throw in your code there, and I will get to it as soon as possible. Let me see if I can send accumulators, Boolean Flags. Let me open this in one that I haven't done yet. Oops. I've got oh my gosh. Can I not? Is it not going to let me go through? Okay. I've got so many. March 4th, 2019. I've got to like leave some of these cohorts that are super ancient. Okay, let's just do April. Let's do this one. And then I'll come into accumulators. And that'll be Boolean flags, and we'll go to number 3. Okay, I noticed the reason I'm changing from the one to the other is I noticed that I had completed that one in basic prep, so I didn't want to expose the answer before we got to it. Okay, so here's number 3. Oops. There we go. So this says write an integer sum accumulator that uses a Boolean flag to exit once the sum of numbers exceeds 500. Your accumulator variable should be called numSum, numList, and your Boolean flag should be called exceeded 500. Cool. And we do have the code posted. Oops. Let's see. I have to shoot. I'm gonna have to copy each line one at a time. If you, it's not a big deal. I know Slack takes some getting used to, so no big deal here. If you surround your Slack message in single tick quotes, it will do a one line format. But if you do 3, 1, 2, 3 ticks, it will give you a whole block of multi-line formatted code. I'll do it one line at a time this time. Okay, sorry. There you go. Oops. There we go. Almost done. Oh, come on. There we go. I am forgetting how to just use my computer. Okay, cool. So let's see here. And just for reference, the multi-line formatting will look something like, oops, it'll look something like this. Not a big deal. Yeah, like I said, it definitely takes some getting used to with Slack. Let me just double check that, make sure I got everything. Okay. Cool. All right, so this is the code that's being asked about. So the accumulator should be called numSum, that's good. And the Boolean flag called exceeded 500. Is that what we have here? It is. Good. So those names are important. Sometimes I'll see people do this where, you know, they'll change the name a little bit, maybe even in a way that's hard to notice. Like it might seem trivial to like put that underscore in there, for example. So, but yeah, you got the names of the variables right on this, so you're good to go there. Okay, so our goal here is write an integer sum accumulator that uses a Boolean flag to exit once the sum of numList exceeds 500. So it wants to exit the loop, so we have to use a break keyword at some point here. This is kind of funny because this using a Boolean flag here doesn't really make sense. It's kind of an odd problem to ask for a Boolean flag. We can do it, but there's just kind of an odd redundancy because we have to check this condition that's a little bit different. So we have to have these two conditions, and literally this code would work fine if we just did this or did this and we're not using the Boolean flag at all. It would do exactly the same thing. But so it's kind of odd to like have, we have an unnecessary condition. There's an unnecessary level of complexity to this, but it is what it is. So we will break the loop, or we will set our flag equal to true when the num sum is greater than 500, and then we'll check if the flag is true, then we'll break. It didn't work. Okay, what did I do wrong? Let's see here. Num sum is not defined. Interesting. Because I totally didn't define it. Let's include that. Cool. One thing I want to, it's good to that you brought up Boolean flags. I find a lot of people struggle with understanding Boolean flags, and I think it's kind of one of those things like you're sort of you want to see what the nuance there is, and they're kind of like, it's easy to like look at Boolean flags and think, okay, I must be missing something. I must be missing some piece of understanding. I see a lot of people. I'm not sure if that's what's. I'm not saying that that's what's happening with the person who's asking this question, but while we're here, I figured I'd just mention it because I see this pretty frequently with a number of people, and I think it's like you want to understand what you want some big reveal, and it's just like, well, you start a Boolean value, you have a flag variable. It starts as true or false outside the loop, and then under some condition, you swap it from true to false. I'll show you something. I'll show you kind of a cool usage for them. Also, if anybody else has any other questions regarding this, including the original poster, feel free to put those in, or any other questions. Go ahead and put those in, but I'll just talk about Boolean flags here for a second, since we're here. So one cool thing that you can do with a Boolean flag is something that I call a Boolean latch. And I know there are like a latch is a formal concept in certain like logic problems, but so I don't know that this is actually technically a latch. I'm not sure. I suspect it's not formally, but it's a term that this is a pattern that I figured out a long time ago, and I was like, I need to remember this, and then in my head I just kind of gave it the name Boolean latch, and it utilizes a Boolean flag. So let's just call this flag equals false, and we'll say let's do something like for in list. Let's have a list. Let's have a list of list equals 5, 3, 9, 8, 7. 5, 2, 4, 3, 7. Okay. So I'm trying to kind of think about this a little bit, where the evens and odds are. So let's do, this is an even. This is a number that is after an even, and this is an even number, and this is both an even number and a number that's after an even. And this is also a number that's after an even. So let's say my problem is I want to do something ACC, let's call this ACC list for accumulator list, and let's call this SRC for source list. So SRC. So there's our source list, and here's our accumulator list. So this is going to have a Boolean flag and a list accumulator. And let's say I have something when you could kind of just pick an arbitrary pattern here or something. Oh, how did that happen? There's your even number. There's a number after the even. Okay. Okay, cool. So let's say what I want to do here is every time I encounter an even number, I want to raise the next number to the power of that even number that I encountered, right? So in this scenario, I would want to raise, oops, too much, many spaces. I would want to raise 7 to the power 8. And then here I would want to raise 4 to the power 2. And then since 4 is also an even, I would want to raise 3 to the power 4. Yeah, okay. So you can see this pattern is not that convoluted. It's pretty, straightforward. Just when we see an even number, we take the next number and raise that number to the power of the even number. Writing this, there's a number of ways to achieve this, and this is just one of them. For a given circumstance, it may or may not be the best one, but it's just one. The Boolean latch is useful when there's a number of things it's useful for. One place that I know that it can come in handy is when you are iterating through a list and you encounter something, not just a list, you're iterating. This could be in a while loop or a for loop through a list or a range or whatever. You're iterating and you encounter a situation in one iteration of the loop that tells you to do something in the next iteration of the loop. So what this is saying, we encounter this 8. If 8's an even number, we encounter an even number. The next iteration of the loop, one way we can think about this problem is we can go to the next iteration of the loop and perform this operation by raising 8 to the power, or excuse me, 7 to the power 8. So we can remember 8 and then perform that operation in the next iteration of the loop. So let's get into this. There's first of all, let's check if I mod 2 equals 0, then it's even. So if 2 goes into I with a remainder of 0, then we know it goes in evenly, and that's an even number. So since an even number is a number that's divisible by 2. So we'll say we want to ACC list dot append. No, we don't want to do that yet. Sorry, I stepped in my head of myself. So if I is even, we actually want to swap our flag. We'll say flag equals true. Often I'll check my flag first. So I'll say if flag. First thing that I do in my flag condition is flag equals false. or true depending on whatever, you just swap it back. You want to make sure that it can swap back. Then this is the condition where I'll raise the current I to the power of the previous I. So I will need to capture that previous number equals I. Okay. So this is a little bit tricky, but this is going to be 7 to the 8th. Then we're going to get 4 squared, which is 16, and we're going to get 3 to the 4th, which is 81. Just like that. Oh, okay. And we have a follow-up question to the previous one, to the previous question that I took, to this one. I'll get to that in 1 second here. But yeah, this is just, I'll just kind of wrap this up really quick. This is just well, I'll title this Boolean Latch. Oops. Want to do that? We'll do that. Boolean Latch. So what's happening here, we set our flag to false. We check our flag in our loop. If the flag is true, we want to reset it to false. We can't forget to reset it to false. And then we'll perform our special operation. And then we'll check the condition that will turn our flag to true. And then go from there, right? So the effect that this has is, you can imagine some value of I. We're seeing if I is an even number. When we set flag to true, and then the loop ends at the beginning of the next loop, the flag, instead of being false, is now true, right? So essentially what this allows us to do is pass information from one iteration to the next iteration. So we're passing information in the form of this Boolean flag, and we're passing information in the form of the previous number as well. So we're taking both of those pieces of information into the next iteration of the loop. Cool. The follow-up to this is the original poster of the previous question is saying they see the problem was that they're trying to use done instead of break. Yeah, I did want to mention that. So there's that line about done. Yeah, so it was like done was being, it's semantically, it's great. Right, so there's this sort of secondary Boolean flag. I definitely get the idea that's being expressed here. And in order to do that, we have that that break condition or that break keyword for loops in Python. Yeah, cool. And could I explain why? Could I explain why the flag example worked when you didn't? Oh, why it worked when I didn't define previous number? How did it know? If it actually didn't work. If I didn't define previous number, it would not have worked. If I don't make that happen, then I'm gonna get this name error because I never defined that thing to raise it by. There are other ways of doing this. I don't have to necessarily capture it in a variable, but yeah, I might have done something else that made it look like it worked, but it needs that previous number variable in order or something to like find the number prior to the one that you're in. You could enumerate and do like the index -1 or something, but yeah, it won't actually work with that. Cool. Hopefully that's helpful. I'm hoping I understood your question correctly as well. You know, I mean, feel free if that's not what you're asking, feel free to let me know. Okay. Just trying to think if there's any other notes for this. I'm just going to give a minute for this. Just if anybody has any other questions, this is a topic that, yeah, feel free. If anybody's got any follow-up questions, or if I was able to answer your question, the person who's asking, let me know. It's helpful for me to know if you actually got the answer that you need, or if you have a follow-up. One thing I want to emphasize here is, you know, aside this Boolean latch pattern it's kind of neat. Almost every, I'm trying to really think of a place where I've used it that I couldn't have accomplished the same task in some different way. Sometimes it's been kind of a nice tool, but it's just kind of a thing that I do sometimes. Often there's a better way, or at least another way that's going to work fine. So I wouldn't want to frame this as like, oh, you got to know the Boolean latch. It can be useful at times. There are other ways that I could solve this problem, though. I kind of think that that's basically the case for when it's applicable. There are other ways. Boolean flags in general. I'm trying to think of like, often when you're writing a Boolean flag pattern, there kind of is usually a better way of doing things. To be blunt, but often like you can think about a problem using a Boolean flag, but there's, at least in the examples that I'm thinking of, there's always like a different way of thinking about the problem that's a little more desirable. So it's not that, well, if you're using a Boolean flag, you're doing it wrong or something. It's just that they don't come up that much, really. So, you know, if there's a part of, you can really kind of back burner this. It's worth understanding ultimately, but it's not something like list accumulators or integer or dictionary accumulators, something that you're going to use pretty frequently. So we got a response here. Thank you. Not to dominate this discussion. No worries. It's kind of a slow day today, by the way. I worry that people will think that they're asking too many questions, but from my perspective, yeah, like I think I want to create a like an open, you know, environment for people to ask questions, and I think it's totally fine. I don't think you're dominating the space or anything. Let's see. The previous number doesn't seem to show how it means the number before I. I see. I understand. So yeah, this might be a little bit weird. Let's do something like this. Let's track the value of I, and let's track the iteration that we're on. We'll call the first iteration 1. And the value of I for iteration 1 is going to be 5. Okay, so I'm going to go through 5. We're going to see if flag is true. First iteration, flag is false. So let's do this. Let's track flag as well. And for good measure, since we're using, let's create a previous number. We'll start it at let's start it at none, because it shouldn't really have a value at this point. We'll just track all these variables. So previous number is equal to none. Let's do this. Okay, so for iteration 1, I is equal to 5, flag is equal to false, previous number is equal to none. It hasn't been assigned anything yet. We just have our initial starting values. We could even track ACC list, but that's kind of changing the least, so I'll leave that one out just for the sake of simplicity. So since flag is false, we check flag. We don't run the code in there. I is 5. We're checking. I'm just going to simplify this. If I is an even number, which it's not. 5 is not an even number. Let's do this. Do it in the opposite order so we can kind of go down. Previous number doesn't apply. So this condition is false, this condition is false, next iteration. So second iteration, flag is still false. We move to this one, so I is 3, previous number is still none. Flag is false, so we don't do anything. 3 is an odd number, so we don't do anything. We move to the next iteration. So here's 3, iteration 3. Flag is still false. I is now 9. You see where this is going. I is an odd number, so we don't do anything. This condition is false because flag is false. This condition is false because I is an odd number. So let's move on to the next one. And here's where things start to change. So iteration 4. So we've gone 1, 2, 3, 4 iterations. Flag is false. I is 8. So here's our first even number. So flag is still false. We don't run this code. 8 is an even number, so we run this code. Flag is true. Previous number is I. So previous number now equals 8, and flag now equals true. Okay, so let's go to the next iteration, iteration 5. So here, this, I believe this moment is the answer to your question. So we're on iteration 5, flag is now true, I is now 7, but previous number doesn't like follow I. What we did is we captured the value of I in previous number at this stage. I changes because of the for loop, but previous number doesn't follow I. It captured that value 8, so its value is still 8. Right? From the previous value, right? So two things happened. We're on iteration 5. Two things happened in iteration 4 that have persisted to iteration 5. One is we changed the flag to true, and the other is we changed previous number to equal 8, which was the value of I in that iteration, in iteration 4. So we've captured that 8. So starting through iteration 5, flag is true. We're going to reset that to false. I stays the same. We append to the list, which, like I said, I won't note that here. We'll just remember. We only do that 3 times, so it's not that big of a deal. We append to the list. And then, since these are 2 consecutive ifs, because it's possible that even though the last one was an even number, that this one could also be an even number, right? So we'll check again. If I is an even number, I is 7, which is odd, so we're not going to run this code. And then et cetera, et cetera. So that's we could carry this on iteration 5, 6, 7, and 8. So iteration 7 and 8 will be similar to this, right? But iteration 6, we're going to have this. We changed from true to false. We did not capture a new value of previous number. Maybe we could do like previous number equals none here. Maybe that feels a little like cleaner or something, but I don't know. I don't think it really matters. It's not really doing anything. So, but yeah, we'll go on down the line and go from there. Cool. I got it. Thanks so much. Don't think I would have been able to think of that on my own yet, but it makes a lot of sense and kind of cool process. Yeah, cool. Good. I'm glad you got it. When you're trying to think through looping logic, when I started doing this thing, like, okay, let me just take a note, and I always leave. I mean, this is what I like to do. I always like to just leave all the notes up in the top of the loop, and then just count the iteration. Usually, I like to start at 1. You could call this index and think about it like as 0, but there's certain like iteration problems where index doesn't really apply. But just whatever makes sense to you, and then keep track of the values that matter to you, that you're interested in. You don't necessarily have to go keep track of everything. Like I said, I didn't keep track of ACC list because I wasn't as interested in that, even though it was kind of the point of this whole thing. The point was kind of understanding this Boolean flag. So just keep track of the values through each iteration that you're interested in. And one cool thing you could do, I didn't do this time, but you can you can copy and paste that at each snapshot. So you have, well, here's all the states of all the values in iteration 1, iteration 2, iteration 3. So you can make a big kind of note or series of notes on each iteration and keep that as part of your note-taking system. So that can be a really helpful thing for understanding more complex loops, code in general. Cool. I believe you mentioned you had another question. Feel free to pop that in there. I'm not getting the sense that anybody else has a question at the moment. It's currently open season on asking questions, so if you've got one, feel free to get it in there, and I'm happy to go through it. I'm gonna give folks just like a minute, just one quick minute to get in questions. All right, I want to see any other questions at the moment, which is fine. Like I said, do feel free to pop them in there if you want. Normally we wrap up, so I'm in Mountain Time, it's 5:18 for me. Normally we wrap up at 5:30 in my time zone. So if you have a question, now or soon is about as late as you'll be able to post it for me to get through it. So it's basically last call for questions at this point, unless it's a quick one. So I'm going to go through the material. I don't see anything else in there at this point. So I'm just going to go to the next part in here. comments. Let's talk about comments. So comments, they're pretty simple. We have two types of comments. We have single line comments, which is just anything after a hash mark, anything to the right of a hash mark. So I want to comment out a whole line, my line of code. I can just comment that out. A lot of times you'll see me do print, hey, something, I don't know, print something. You'll see me take a comment at the end of the line. This is less common to do, but I like to do it. It just makes it, you know, if I can fit it on a line without it wrapping, making my code look weird, I'll do it this way. And it's a good way to just take a quick note on this line does this thing, you know, or, you know, maybe you're testing a function and you're saying, this is what I expect this to do. Or maybe, like I said, maybe you're getting an error and you want to comment the whole thing out and you're saying, well, I'll get this error if I run this line of code. And you know, that can be part of your notes for learning a given feature in Python or a new library or something. Or you can keep it in your code and say like, hey, there's a reason I'm not, you might want to run this line of code, but if you do, you're going to get this error and it'll remind you or whatever. But so you can comment out a whole line, and you can comment out part of a line, but you can't just comment something in the middle of a line out and then have it uncommented on the same line. So that's a single line, what we call a single line comment. There's also a multi-line comment. And there's two ways to do a multi-line comment. You can use two sets of triple single tick quotes like this. You can also use two sets of triple double tick quotes. So not, you know, no big difference. I think it's easy to like look at this and make an assumption that one will do something different than the other, that triple singles are going to be different than triple doubles. They're not, they're exactly the same. They have exactly the same role. You may notice that I have these really weird like bars of comments in all of my streams. And the reason I do this is one of the first things I ever figured out when I was first learning to program. And I'm the only person that I know that does it. But these are comment blocks. And I have this little note here, un/comment to d/activate, right? So I could read this as uncomment to deactivate. Right now, this line is commented out, and it's because it's got a hash in front of it. But if I uncomment that line, it turns this block into a multi-line comment. And if I comment out that top line, it turns this line into a single line comment. And since there's hashes in front of this ending triple quote here, which would be the ending of this, the matching pair to that, right? When I comment this line of code out and make this a single line comment, these hashes, or really just this first hash, just makes this line also a single line comment. And what that means is now I have two single line comments. The code in between here is valid code. But if I want to, if I uncomment this line, it turns the whole thing into a multi-line comment, and it just comments out that whole block of code rather than just one line at a time. So it's just a way for me. I find it really useful. Well, I found it really useful. Very, like I said, it was like the first meaningful thing I ever figured out how to do. And I don't know why. It's like I spent hours figuring it out. I was like, I wonder if I could do this thing. I spent like quite a while figuring it out. And I used it in my note taking when I was very, very first learning to program a long time ago. And it was helpful for that because I could do a little project and then, you know, just do that, uncomment that line, and just have that whole thing in a block comment, and then move on to the next thing and the next thing. And then I had this big document where all my code was, so it was easy to search through that and find other things that I'd done and reference my own code. So I found that to be a useful note-taking strategy. It's actually something, literally, see this document up here is called notes. It's something that I still do to this day. You can see this thing is huge. I don't know how many lines of code are in this. I probably need to retire it soon. Oh, well, this one's a bit short. We're getting up to 3,000 lines of code. So I'll usually retire my notes document when it gets around 10,000 lines of code, because it starts slowing down my text editor whenever I open it. It starts kind of bogging it down. So, but I still use that technique today for note taking. And this notes document is actually the culmination of basically my streams. You know, whenever I stream, I just copy what I do in here and I paste it in my notes document. And then that way, if somebody asks me like, hey, you did this thing on stream a week ago, you know, what was that? Can you send me that code? Or I probably don't remember what the code is, but I can look it up in here and find it in here. Occasionally I'll do something that is new to me and I'll put it in my notes document. Everything goes in this notes document. And then if I, you know, maybe I learn a new feature and then don't use it for a while and need it a few weeks or a few months later or something, I can find it in one of my notes documents somewhere. So that's a useful thing to be able to do. And then you can just comment, uncomment whichever part of it that you want, play around with it. So I find this useful for, I've found these comment blocks useful as a learner and for streaming. So in teaching, I found it useful as well, because really I just want to open a document and then just kind of go through it, march through it. And this allows me to, you know, explore a concept, comment it out really quickly, and then go on to the next concept. And I don't have to like delete it or comment out all those lines or something. Keeps things clean. So to be clear, this is just something that I do. It's not something that you have to learn at all. I don't know anybody else that does these weird comment blocks like this. But if you want to use them, let me pop one in. There we go. You can copy paste that and use them in your own if you want to do it. How do you revert back and forth? Oh yeah, I should mention this, right? This like turn it on and off like this. One thing you could do is just delete this hash mark, and then when I want to comment it out again, I'll just hit Shift and 3, and then I'll add that hash mark back in. But to quickly make an entire line, turn on and off or off a comment on a single entire line, there's a shortcut that works for every editor that I'm aware of. Replit, VS Code, Atom, Sublime Text, Jupyter. So any modern editor will have this same shortcut in my experience. On Linux and Windows, it's going to be Control /. On Mac, it's going to be Command /. So / key is the key with the question mark on it. Yeah, so just Control / or Command / and just hit that keyboard shortcut, and it'll just comment out or uncomment a line just for a single line comment. That's how I can quickly switch like that. If you know one keyboard shortcut, that's the one you should know. All right. Yeah, so they're useful for a variety of things. I have this sort of a slightly convoluted way of taking notes with these, weird comment blocks. They're useful for if you just want to leave like a quick note in your code. I use them for testing. I mean, probably the most common thing that I use a comment for is to just like if I wrote a line or a few lines of code that I don't want to, I wrote those lines and maybe there's meaningful logic in there that I don't want to just delete, but right now I don't want to run them. I don't want to delete them, but I don't want them to run in my program. So I'll just comment them out, run my program with those lines commented out, see how it behaves, and then, maybe uncomment them later, so it's very common that you'll write code, you'll get a little ahead of yourself and you say, oh, let me comment out these lines and just try this one thing really quick, and then I'll uncomment those and run it again. So it's really common. That's usually what I use comments for. It's probably the single thing that I use them for the most, is just commenting out a line of code and then coming back to it later. I'm wondering about that last week. Yeah, cool. Yeah, it's a very useful keyboard shortcut. I feel like it's like, I should mention that keyboard shortcut more because it's, I feel like it's like almost a rite of passage. It's like your first keyboard shortcut that you learn, that starts making coding easier, and then you can learn more and more and do like multi-line selection stuff and things like that. But anyways, we're about at time, or we are at time. This is the normal time that I usually like to wrap up. Occasionally I'll go a little later or a little earlier, but yeah, so this is a great study hall. I had fun. I appreciate the people who had questions, and I think that's, you're really contributing to making study hall useful for everybody and fun. Well, fun for me at least. I'll speak on my own behalf with that, but I hope that this is fun for you all, and that you find it useful and you're learning something. Do feel free always to bring me your questions. If you have any other questions that I wasn't able to get to, feel free to just send me a direct message anytime, and I'll get to it as soon as I can. Aside from that, if you're in Premium Prep, I will see you this evening. And my next study hall is going to be Monday. Tovio is going to be taking study hall on Friday. Their study halls are probably going to be a little bit different than mine, and I think Tovio has a lot of really cool things to say. So I would recommend that you go and check out their stream when they have that this Friday at the same time. Yeah, cool. I'll wrap up there. It's been great, and I'll see y'all soon. Cool. Bye-bye.